Okay. All right. We'll continue doing atomic theory. I haven't recorded anything yesterday. I didn't record anything yesterday. Therefore, if you are away, just need to get the note later. So perhaps a bit of section for you. We are in Unit 2. This is, I guess, second part in Unit 2. So, atomic theory. Now, you'd have finished writing this down, this definition. So, atomic theory is to do with a model that people have been using, and that's been changed over time. We watched the What is the Universe Made of video yesterday, so we can move on to the next slide. All right. The atom is the smallest indivisible particle. Indivisible.
Invisible.
It should say indivisible. Why does it say invisible?
Indivisible.
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 Like it can't be divided.
Indivisible.
Isn't that what they say?
Yes. So that means that you can't divide. That's the smallest particle to make a substance, smallest substance. Right. So write that line, please. I should write it because I said write down what I write on the board. So, what would that mean when we say indivisible? Can't divide it. So you just read the English word there. In chemistry, that's where we really end up to. I mean, in an atom, yes, you can find subatomic particles, but they do not define any substance. They don't define element. If you just look at, a bunch of protons only. All right. Atoms define what element they are. Okay. So the atom is an indivisible particle, and they're the smallest. Define the particle is. Does that make sense? So it's the smallest thing. And all the elements you can find on the periodic table, you are talking about one type of atom in each box, okay? All right. And also the atom of an element can be split, but when you split, what's going to happen? You're actually talking about some other element. Does anybody know what the process is called? Something that uses splitting of atom as a power source. Can anybody put the hand up? I'm hearing it somewhere.
Nuclear fission?
Nuclear
Fusion.
Which one? I wonder. Fission will be splitting. So you are probably right. Okay, I couldn't just hear from here. Fusion will be combining. So that's what suns and the stars do. Okay, sun and the stars do. Okay. Fission will be splitting. So if you start with say uranium, so you being Mr. Homer Simpson, adjusting how much uranium bar is exposed to water, yeah, that is doing its nuclear reaction to heat up water, and you get a lot of energy from it to spin a turbine. Yeah, so that's what his job is. I don't know how he got the job, but yeah, he got the job. So if you are splitting, say, uranium and getting power out of it, you are already talking of a different element. Yeah. You're dividing, meaning you're creating new element. It's in the simplest language. If divided, elements change. For example, uranium can split into, I think one is krypton. There's actually a diagram here. Krypton and Ba, barium. And it spits out free neutrons, which would cause a chain reaction. Yeah. All right. Well, let's keep looking at the definition of that. So when you look at different type of atoms, you are talking about different elements. Each atom has got certain number of things in it. Yeah. So if you change the number of things within an atom, you're already talking about different elements. All right. Now, I've been saying element, element, element. Well, you might just say that, well, that's all what you see here. But what's the definition? Here it is. Definition of an element. Element is a substance made up of only one type of atom. So focus on the word type there, okay? Keep following. So element. Definition is that it's a substance made up of one type, underline type. Okay. So if you pick up a charcoal, okay, what type of atom, how many types of atom would you expect to be in that?
One.
One. And what element would that be? Charcoal. Charcoal. Thank you. Carbon. Yeah, charcoal. I might not be saying right. Charcoal, yes, it should be, in theory, made up of only one type of atom, which in this case it's carbon. Yeah. Speaking of carbon, it can come in different shape. Yeah. Charcoal is not the only thing that carbon is in as a naturally occurring thing. Or you can even make carbon into something else artificially. Sorry, I just said, so let's say that was a charcoal, this black thing here. It could be a coal. Well, let's say that was purely carbon. Yeah. What would that be?
Diamond.
Thank you. Diamond. Yeah. Diamond, believe it or not, it's pure carbon. If it's got color like ruby or emerald, they would have some other elements in it. Okay. So pure carbon can make diamond. George?
How can diamond, how do they exist?
How do they exist?
Yeah.
If you have got very strong muscle powers, then just try compressing charcoal into really small particles thing. You might get diamond.
Do you find diamonds in the ground?
Was that a joke?
Shallow?
It's not a joke because physically you can actually make them. So if you pressurize carbon enough, you can make it into diamond. High temperature, high pressure, that's what's needed.
But
where can you find them?
You can still find diamonds. So can you?
Correct. And where do you find them? Underground. And in underground, you would expect a lot of pressure, because a lot of mass is on top of it, and you would happen to have maybe some heat from mantle or other volcanic activity. Yeah. So naturally occurring diamond, and the big ones are more expensive because it's very hard to get. It's very rare. But if you want to artificially make them, you can. For example, I do a lot of woodwork. Wood cutter, the tile cutters usually have particles of diamond. That's usually artificially made. Okay. Well, how do you make it? Well, you just add a lot of pressure and heat to it, and you get diamond out of carbon. What would this be made of? One in the middle.
Wood.
Usually steel, I would say, but something lighter, something that.
Plastic.
Something. Is there any car enthusiasts here? I don't know. Anyone wants?
Iron.
No, we are still talking about carbon here. What could this material be? It's a wheel, yeah? Carbon fiber, thank you very much. So it's a fiber made out of carbon and it's weeded into a shape of wheel. Okay? Why would people make this out of carbon? Strong. Okay, yeah, I'm hearing strong. Yeah? It may be durable. But compared to steel, would that be more durable, you reckon? Maybe.
Is it cheaper?
Probably steel is cheaper. That's why we see more of the steel wheels.
Steel would be cheaper.
Yeah.
Water.
What is that? No. Yes, it will be lighter. Carbon will be much lighter. So if you see like racing cars or sports cars, you might see a lot more carbon fibers used more than steel or aluminum. Okay? So that's a property that we want and artificially made, but purely from carbon. Yeah? But believe it or not, one strand of fiber that you can make from carbon is much stronger than same diameter wire. Yeah? So steel can be weaker compared to the one fiber of carbon. If you put the carbon fiber together and in a special manner, you can get a material called graphene. People believe that graphene has got the very exciting future because this graphene could potentially be made into clothing, which can project an image. So it could be used for camouflaging. Could make you into invisible, could have an invisible wall, or you could walk around a mobile which is flexible, or roll up a TV, newspaper, whatever. Okay? But graphene, again, is made up of carbon only. Yeah.
It's because I was in the song room Chelsea.
All right. Now graphene is a thin sheet this time, okay? Thin sheet of carbon, okay? Sheet of carbon. Yeah, and if you make them layered up, well, carbon is also it's a non-metal, but it can conduct electricity. That's why they're used for those kind of things. The word that describes an element that can come into different forms is this word here. Allotropes. Let's write that down. So what does that mean?
Wait, were you asking?
Let me ask you then. Yeah, what would that allotropes mean? I'll start with an element.
The different types of carbon?
Similar clones. Different types of substance, let's say.
Types is a very big keyword.
Good. So different types, I think, type of substances. Now, type can also, in this case, mean appearance, property. So it could mean appearance or property. which is made up of what? What do you think? Different types of substances like these.
Which is made out of the
Made
same
out of
element.
same element. Well done. The same element. Good. My red is dying, so I might not use it today. Unless I have another one.
I was going to say that ruins your theme. You know how you have the important, very important.
I do have-
Red is very important, isn't it?
Yeah.
It's like remember for test important.
Yeah, that important. Okay. Alrighty. Now, we have talked about elements and definition of it. What do we mean by atom? Let's move on to what they look like. Structure of atom. Now, I would like you to draw. Now, could be a bit hard if you're typing it up, typing the notes up, but let's try drawing them. You have a lecture note on Canvas anyway. If not, well, you please expect some sort of drawing questions in the tests, and you will keep getting drawing questions in chemistry. So yeah, practice drawing. That's what I'm trying to say. Yeah, structure. Atoms, an atom doesn't really make much difference. Alright. Now, every atom you look at, there are a few different parts to it. Okay. Does anybody know the name of the center part? Ooh, good. Who did you have for year 9? That's why. Well, that's good. That's good. I like it. All right. In the nucleus, which is the center part, what do you know that there are?
Yeah, I remember those days.
All right. I just drew 3 red dots. Now I'm representing protons with red dots. By the way, what's the charge on protons? And you guys are right too. I hope there's a common knowledge between everyone here. Protons are positive? You all
Mr.
good?
Baldwin was good too. He was a great science teacher.
Alright. What else are there in the nucleus? Neutrons? Neutrons? I heard that from someone else too. Good. I'm gonna do 1, 2, 3, 4 neutrons pretty deliberately. If you haven't got many colors, well, try your best. But now, surrounding the nucleus, what would you find? Electrons, and electrons are in. Everyone should know. Different levels of. I heard that. Shell. Well done. Yeah, energy shells, electron shells. All right. So I drew 3 electrons, and they are.
Oh wait, positive. Don't be. Free.
Orbiting around on the shell. It's not really a realistic model, but let's go with that because you see that on Buzz Lightyear, yes. And the Big Bang Theory on series. So, I love the show. Alright. So, blue negative electrons. Does anybody know the charge of neutron?
Neutral, isn't it?
Neutral. That's why it's called neutral.
Yeah. Electron is the only one that doesn't give it away. But it's easy to gather because it's the only one that doesn't give it away. You know what I mean?
It depends on the element. We'll talk about it. It depends on the group, I should say. It depends on the group. Electrons can be given off really easily. Some elements once you will learn.
Don't confuse me already, please don't.
Yeah, no, we'll talk about that as a class. How's your drawing going? It's a practice that everyone needs. My drawing is not perfect, but I try. Oh, I haven't written nucleus anywhere, have I? So nucleus, I'm just going to add someone like that. Nucleus. English question. What do you think of the plural of nucleus would be? Nuclei. Good. Yeah, like cactus, cacti, octopus, octi, octopi, platypus, platypi. I'm pretty sure you can. Platypus, platypi.
I just did it all in circles.
Alright.
Like that.
Sorry?
Is it okay to draw it like
Yes,
that?
yes, that's fine too.
Because that's how I did it. We'll either give you a pass mark in the test.
Nah, you won't be drawing like this in the test, right? You will draw like that. On the wall? On the wall? Yeah. Electron shells? Yeah. You'll be drawing like that. Alright. Now, I hope we have already established what particles they are, what charges they have, and what location they are in. Electrons I haven't really written here, but they're electron shells, yeah? Electrons live in electron shells. I'll cover one more thing and we'll do an activity.
Oh, yay! What was it? Do an activity. Oh. You could sound more excited, Mackenzie. Well, that's about what you
It's okay.
Alright.
Can I take a photo so I can draw my book?
No, you have a lecture note in Canvas. Why do you have to take a photo? Alright. Now, mass of subatomic particles. Now, which one has mass out of those three? Put your hands up. And if you can tell me which one would have mass. Proton. Proton definitely does.
And electrons.
And electron, you think? Good to make mistake. No. Thank you for being a sacrificial lamb here. Electrons don't. Okay. Well, it does, but it's very, very, very low. No, but everyone learned from you. which is great. Thank you. Oh, thank you. I appreciate that. All right, so protons have mass, electrons, they don't. All right. One AMU. Alright. What about the rest? Well, one left one. Neutron. What do you think? Neutron would have or wouldn't have? Who would vote for neutron has mass? 1, 2. Neutron doesn't have a mass?
Well, it does, because
Yeah. Well, what we have talked about yesterday was if you see, say, nitrogen, which is number 7, and it says 14.00 as its mass number. 7 is proton, right? What else is in there then? What makes up the 14?
Yes.
So neutron actually does have to have some mass, okay? So you do all good. Yeah. So, 1 AMU it's called. Yeah. Kikuchi? No. Atomic mass unit. Atomic mass unit. I should write it down somewhere. Maybe I should have done in blue. AMU stands for, that's a unit given for mass for one particle, one subatomic particle. Okay? Now, electron. Titan has bravely made mistake for us. Now, it's 1 out of what's the number? 1836. So almost 2,000 times less compared to proton neutron. So we don't consider the electron has mass when you look at the mass number. Okay? So electron do not count towards mass number. Sorry, I used the shorthand again. E minus means electrons. Hope you figured that out. E minus, U is minus on top.
means electron.
Electrons. Electrons do not contribute to mass of an atom. Okay? Okay. Now, having said that, if once you finish writing that down, I will ask you to go to Canvas so you can access this link here on slide 14. I think there's a link actually on Canvas. So go to Canvas now, please, and try making some atoms, 1 to 10 actually.